Now let's try to find out different types of acceleration. Okay. Now, first type of acceleration is uniform acceleration. Okay. So till now, whatever we studied, same sort of definition. When we say uniform acceleration, the body covers equal amounts of velocity in equal amounts of time. Okay, or equal intervals of time. Okay. So if you are moving in a straight path in a car, okay. So in a car, if you are moving, if the change in velocity and the change in time, if it is constant, like for every 10 seconds, if I'm increasing the speed or decreasing the speed by 10 meters per second, okay, so then that becomes uniform acceleration. Okay, then comes variable acceleration. So when we talk about variable, see, name itself suggests, so it changes, meaning the change in velocity and change in time, they're not equally moving. Like for first 10 seconds, I increase the speed by 10 meters per second. Then for the next 15 seconds, 10 meters per second. Next for the 5 seconds, I'll increase by 20 meters per second. See, like this. So this is variable acceleration. Okay, most of the times whatever we do, it's variable acceleration. Okay, then comes average acceleration. So average acceleration, total change in velocity by total time. Okay, so this gives us the average acceleration of the body. Alright, then comes instantaneous acceleration. Okay, now this part is quite tricky to understand, because see, when we talk about instantaneous acceleration, similar to instantaneous velocity what we had, same thing. Now at this particular instant, what is the velocity we need to check? Okay, at this particular instant divided by the time. Alright, that's the reason what we do is we write A is equal to delta V by delta T. Okay, now delta V is very small change in velocity and delta T is very small change in time. Maybe like 0.5 seconds. 0.5 seconds is very small, correct? So delta V by delta T is the instantaneous acceleration. Now we put the limit as delta T tends to 0, meaning the small change in time should almost be equal to 0. Okay, then we call that as A is equal to dV by dt. Okay, so this is what we call as differentiation. Anyway, you're going to learn this in 11th standard. So we have acceleration is equal to dV by dt. Okay, now this is what we call as instantaneous acceleration. Okay, now if you want to see layman terms, very easy to remember is, at that particular instant, what is the acceleration? That is instantaneous acceleration. Okay, now whatever in car and all you see, right? So those are all actually speaking instantaneous. Okay, like at that particular instant, what is my speed? What is my acceleration? They're all instantaneous. Okay, alright, so now I have a question for you. See, we say acceleration, correct? Acceleration meaning either it's increasing. Basically, that is acceleration. Now, opposite of acceleration, it's called deceleration. Okay? It's called deceleration. So, suppose, let's say, imagine you're skydiving. Okay? So, you're falling from 16,000 feet. Now, what we say is, we speed up. We are speeding up because of acceleration due to gravity. Correct? But, let's say you start falling. Then we say that at some point of time, the body is at free fall. Right? Now my question is, do we keep on accelerating or do we maintain a constant speed after some point of time? Okay? So this is the question. So in the next video, you are going to see the answer.